and welcome back Year 5 and 6 to the Key Stage 2 Science Learning Journey. Now we started this learning journey on Monday the 18th of January 2021. So if you haven't watched the first two videos, which are the plan and do videos, then you will need to go back and do those to be able to access this part of the learning journey. So we're going to begin this video by reminding ourselves of our outcomes, what we're hoping to achieve by the end of today or tomorrow. We're going to recap our learning so far. We're going to have some new learning, which will enable us to answer our inquiry question. And then you're going to have a task to take away and to share with your class teacher on Class Dojo. Okay, should we get started then? Now, our outcome, so what we're going to achieve by the end of this week, is to carry out a scientific experiment. We're then going to write a lab report, which we already started, including question, prediction, method, data, and a conclusion. Some people are going to take their learning a step forward, and they're going to turn it into a learning journey, which includes all of the above, including posters, diagrams, a glossary, and some of their own research. So, our inquiry question this week. How does the number of fins impact the distance a rocket travels? So, for example, if a rocket has more fins, will it travel further? If it has less fins, will the distance travelled decrease or be smaller? Or could it be the other way round? More fins mean less distance, and less fins mean more distance. That's what we're trying to find out, isn't it? Now, our gateway is explorers. And we've been following our passions and seeking challenge all week, aspiring to be the best versions of ourselves. And lots of us have been really challenging ourselves this week to ensure that we're including scientific language in our writing, our diagrams are accurate, and that we built the best rocket we could. We also have had some science knowledge to learn this week to do with forces, because we can't understand how fins impact the distance unless we have some knowledge of forces. So Year 5 and 6, if you could pause the video now please and just take a few moments to remind yourself about what you know about the forces that play against a rocket. Okay, hopefully then you've remembered that thrust is a force that pushes or pulls to create a movement. Gravity is the Earth's pull towards the centre of the Earth, meaning all objects fall to the ground because they are being pulled towards the centre of the Earth. And these forces are pulling in opposite directions with a rocket. The thrust is pushing the rocket into the air, and gravity is pulling the rocket back down to the centre of the Earth. The third force that is pushing against the rocket is air resistance. And air resistance is the force of air pushing against something as it moves. And often it can end up slowing down an object. So we planned our experiment, including making our rocket and considering what a fair test is. Now, can you remember what a fair test is? So a fair test is one where only one variable is changed, while all the other variables are controlled or kept the same. So our one variable that changed this time was the amount of fins. The first time we launched our rocket, it had no fins. The second time it had one fin. The third time it had 3 fins. The fourth time it had 4 fins, and so on. Can you remember what variables were controlled or kept the same? There was quite a list, wasn't there? That's right, we had to ensure that the thrust or the force used to launch our rocket was the same. That means if we took a big deep breath for when we first launched our rocket, we had to take a big deep breath each time we launched our rocket there on in. We also had to make sure the fins were the same size, that we carried out our experiment in the same place. And there were a few more things as well, weren't there? Then we did our experiment, so that was the do part of our plan, do, review cycle. And as we did our experiment, we ensured that it was a fair test. Now, as part of the do, we wrote a science lab report. In my previous video, year 5 and 6, there was lots of support about how to write this, including sentence starters and word banks. So if you haven't written your science lab report, don't be nervous, give it a go, really challenge yourself this week, okay, because there is lots of help available. So your science lab report started with your question, then it had your introduction, which is where you explained what you were trying to find out. Then it had your hypothesis or your prediction. Then you listed the equipment or the materials that you needed. And then you wrote a step-by-step method or a guide to what you did. And that includes how to make your experiment a fair test. And then you had a data or results table and possibly a graph if you challenged yourself. So that brings us to today. Now we are on to the review section of our plan, do, review cycle. We want to be able to answer this question by the end of today's video. Now to do that, we're going to need to do the following two things. We're going to have a discussion about what your results tell you. And we're going to have to write a short conclusion, using some science knowledge to explain. Okay, so we're going to think then about our results first of all. Now here's my results table, and I've put in my results that I got when I was at home. They might be slightly different to yours, and that's absolutely fine. Now, my number of fins, when I had no fins on my rocket, it travelled 53 centimetres. When I had one fin on my rocket, it travelled 62 centimetres. When I had 3 fins on my rocket, it travelled 103 centimetres. And when I had 4 fins on my rocket, it travelled 84 centimetres. Okay, so underneath your results table then, year 5 and 6, you'll start by writing the subtitle, the subheading, discussion, and underlining that with your pencil and ruler. And then you're going to write a short sentence or 2 short sentences, doesn't have to be a lot, to explain what your results tell you. Now I've done one here for mine. My results showed that 3 fins enabled my rocket to travel the furthest distance. Any more or any less fins and the distance travelled decreased. Okay, so it's time to pause the video now and write a short discussion. That means explain what your results tell you. When you've done that, come back and we'll be thinking about why. Okay everybody, so why were 3 fins the best or the most optimal amount to enable my rocket to travel the furthest? Why was it 3 fins? Now, understanding why is going to help us write our conclusion, because it's going to give us some science knowledge that we can use to explain, and then our conclusion will answer our inquiry question. So, let's have a look then. We're going to go back to our rocket. Now, our rocket. Now, rockets need to be aerodynamic or streamlined. Okay, so they have a cone on the end. Do you know why their nose is a cone? Well, cones cut through the air easily. If you had a flat nose, one that was more square on the end, what do you think would happen? That's right, a flat nose would hit more air particles as it moved through the air. It would have more air to cut through, and therefore it would slow down because it would be hitting against more air resistance. Now, because we used a cone on the end, and this is this sort of pointy shape, that cut down on our air resistance, reducing the amount of fuel that the rocket needed to fly. Okay, now to get our rocket off the ground, we needed thrust. And in this case, the thrust is powered by our lungs. So we take a deep breath, we blow into this tube here, or our straw. Our breath travels through the straw and it hits the cone, and this is what thrusts our rocket through the air. Now we need our rocket to be airtight to ensure that there is enough thrust for it to take off. If we had any breath leaking out of here, then we'd have less thrust, less force to cut through the air resistance. So how do the fins help? Now fins provide stability to our rocket, and fins help with the direction of travel. So as our rocket is moving through the air and powered by the thrust, air resistance is having an impact on our rocket, and it can cause it to wobble and shake or even change course of direction. Gravity will also be pulling on the rocket, and we're trying to pull it back down to the centre of the earth. Now, while all this wobbling is happening, the fins are providing stability to your rocket. That means they're counteracting the force and they're trying to stop it wobbling. Now, sorry about that, everybody. Now, the more it wobbles, the more your rocket wobbles, the more air resistance it will have, or that it will meet and push up against. This means that it will travel slower and much less distance. Eventually, your rocket will start to fall down to the ground because your thrust has been overpowered by the air resistance and the gravity, or your fuel runs out. Now, your conclusion then will explain why, in my case, my 3 fins, I need to explain why my 3 fins meant that it travelled the furthest distance. Okay, so how do I do that then? Let's have a look at an example. The reason rockets have fins has to do with stability. Sorry everybody, I'm not sure why it keeps doing that. I do apologise. So let's start again. The reason rockets have fins has to do with stability. The fins help the rocket keep pointing in the direction it launched. When a rocket is flying through the air, changes in the air can make the rocket wobble. If it wobbles too much, it can go off course. Having the right size, shape and amount of fins will help make sure your rocket corrects itself when it wobbles. The size, shape and number of fins will change things like your rocket's centre of mass, that's its weight, and how much drag it faces when it flies. Okay, so Year 5 and 6, it's time now just to pause the video, and underneath your discussion you'll need to write the subheading conclusion. That will need to be underlined with your ruler and pencil. And then you're going to need to use your scientific knowledge to explain why, however many fins it was, in my case it was 3, yours could be 2, it could be 1, why 3 fins enabled your rocket to travel the furthest. Okay, you can use my picture and my paragraph to help you get started, but do your best to change it into your own scientific explanation. If you feel that you need to include a diagram, if you think that would help you to explain or make it easier for you, you can. Okay, when you have finished your conclusion and therefore answered your scientific inquiry question, come back to the video for the last part of our review section. Welcome back everybody. So we are at the final part now of the review section. We've already reviewed and answered our question. How does the number of fins impact the distance a rocket travels? So we know that actually it's nothing to do with the amount of fins in terms of how far it travelled, but fins offer stability to our rocket. So we have to get the right number of fins to give the right amount of stability to ensure that our rocket is aerodynamic and can cut through the air resistance powered by the thrust to travel its furthest distance. Now, one of our outcomes then was to carry out a scientific experiment, which we've all done. Fantastic. Not only that, we also made sure it was a fair test, which is actually a step forward from where we were last week. When we did our ice cube experiment, it wasn't a fair test in most cases. Now we know what a fair test is, and we've had a go at carrying out a fair test. So already, if we're thinking about our gateway, we're already making progress in that area as we're seeking to be the best versions of ourselves. We're determined to carry out a scientific inquiry accurately. We've also written a lab report this week, which includes our question, prediction, method, data and conclusion, presented ready to share with the class and your teacher. And then some of us have really challenged ourselves this week to do our own independent research. So we've done all of the above, so we've done all of this part here, as well as creating posters, a glossary and other research presented. So let's think then back to that explorer's question. At the start of the week, you were asked to think, or you were told that we would sort of be thinking about, how have I shown determination and perseverance? Now you've probably done that in lots of ways this week without even realising it. When you built your rocket, did you have to show determination and perseverance? Was there a challenge that you had to overcome to be able to make your rocket? Have you challenged yourself this week to use a vocabulary bank and to apply some scientific knowledge to your writing? Have you created your own glossary as part of a learning journey in your book? Have you created a scientific poster? Have you used a diagram or picture this week? Have you written scientific explanations? Lots of us have shown determination and perseverance in lots of different ways. So, how determined have you been this week? On a scale of 1 to 10. 1 being, I've not been very determined or shown very much perseverance this week. 5 being our midway point. Yes, I've been reasonably well determined, but there's room for improvement. Or you may be towards 10, which is yes, I've been a real superstar this week. Every challenge I've come up against, I've persevered and been determined to overcome it. Where would you place yourself on the scale? Pause the video now, see if you can come up with a number and then a piece of evidence to say why you've put yourself at that number. Okay, hopefully then you've had a little think, year 5 and 6. I know, because I've done this experiment at home, I would probably put myself at about a 7 this week. Because actually I found making the rocket quite tricky. And the first time I did it, I gave up. Which isn't really showing that I'm seeking challenges or that I'm determined to overcome it. So what would I do differently then to get my score up? Now, I'm going to aim to be at 8 next time. And the next time I have to make or do something, even if it's a challenge, I'm going to try and not give up. Okay, year 5 and 6, I'd like you to pause the video again and have a think to yourself, wherever you place yourself on your scale, what are you going to do differently to improve your score? Now, those of us that are challenging ourselves to create a learning journey at home will want to recreate this scale in their book, to mark on their first score and what they're going to try and achieve next time, and then to write a short sentence about what they do differently. So just like I said, I sort of said that my reason for giving myself was a 7 is because I gave up when I created my rocket the first time. But next time I'm going to create or make something, I'm going to have the perseverance and determination not to give up, even if it's tricky. Okay, time to pause the video then, year 5 and 6. You're either thinking to yourself or you're recording this in your learning journey. One final bit when you come back, and then we're finished for the week. Okay, welcome back year 5 and 6. I suppose we've already sort of done this part really, but I think I've put it in the video the other way around, haven't I? I've got myself in a pickle. So we thought about our gateway already, which means what we've got left to think about now, I'm going to delete that bit because we've done that bit already. I got a bit ahead of myself, didn't I? What we're going to think about now is our scientific experiment. Okay. Now, did you make your scientific experiment a fair test this week? Because that was a piece of learning that was key and crucial to our science learning and working scientifically this week. So if you think that your science experiment was not a fair test, that those variables you were supposed to control, well, that all went out the window, then you're going to mark yourself as a 1. If you think, well, I did my absolute best and I think I controlled them all, then you might be somewhere in the middle. And if you think, yes, absolutely, I controlled every single control variable that I was supposed to, I made sure only one thing changed, gosh, I was a real scientist this week, then you can mark yourself out of 10. When you're thinking about your score, try and have a reason why that you're giving yourself that score. Okay, pause the video then, year 5 and 6, and then come back to me when you thought about your score. Right, welcome back. Now, when I did this experiment, I think I was reasonably fair. Now, I've put myself at about an 8, and I'm saying I was reasonably fair. Because actually, the control variables, some of them were really hard to control, which means my data might not have been as reliable as I wanted it to be. So for example, the one that springs to my mind is my breath. I tried really hard to ensure that the thrust was the same each time, and that when I filled my air with lungs, that I gave the same amount of force each time. But I can't guarantee that. It could have been slightly different each time. So therefore, I think my results were reasonably fair, and they're somewhat reliable, but I'm not sure they were a 10 out of 10. So what would I do differently to improve my score? Now, to move myself up to a 9, I think it was really focusing on my breath that would make the difference. So is there something that I could have used instead of my breath? What do you think? I suppose I could have maybe used something like a pump, like a bicycle pump. If I'd pumped air into the tube, would that have made it fly or launch into the air? So to increase my score, to make my results more reliable, I would really be thinking about that control variable and ensuring that it was exactly the same each time. What did you decide to do differently? Now, some people may think about it and they might decide just to write it in a little message to their class teacher. Some of us are challenging ourselves this week as part of our gateway to write a learning journey. So again, just like you did for your gateway, you'll be thinking now on a scale. I'm going to put that scale into my learning journey and I'm going to reflect how much my experiment was a fair test. And then I might write a sentence to explain why I gave myself an 8, for example. And then I'd explain what I do differently to improve my score next time. Okay, congratulations then Year 5 and 6. You have made it to the end of our science week. You have completed your plan, do and review cycle. You have been terrific explorers. You've been seeking challenge to be the best version of yourself. You've written reflections and had reflective thoughts about how to improve your determination and resilience, and how to ensure that your experiment could be a fair test with more reliable data the next time you did it. And you've answered your inquiry question. And I'm feeling pretty confident now that if somebody was to ask you about forces and fins and rockets, that you'd have lots to tell them. A fantastic week, everybody. Now please do share your learning with Mrs. PA and myself on Class Dojo. I can't wait to see your reflections and your review part of the cycle. Okay, well done everybody.